Accessing the LAN and the internet. In this nugget, you systems administrators are going to get your fill on how we can leverage Python to connect to resources on a, say, corporate intranet, a corporate network, as well as going out onto the web to fetch and parse web pages. We'll even go so far as to take a look at FTP connectivity, both client and server, although in this nugget we're going to stay with the client side of the equation. It's just as easy to set up a web server and or an FTP server using Python as well. Lot to do in this nugget anyway, and let's get rocking. Accessing LAN resources in Python. If you've watched the nugget on modular programming, you know that modules, whether they be ones you've created yourself or more likely modules that you've obtained from a colleague or downloaded from the internet or possibly even used from the Python standard library, give us tremendous flexibility in how our Python programs work. As you see in this whiteboard, you see really a very partial listing of what's out there as far as built-in standard library modules that deal with networking, and then some related Python technologies, and then we'll finish with some websites. Just this whiteboard alone is absolutely chock full of learning possibilities for those of you who want to use Python to access LAN or internet resources. Now, on the standard library side of the equation, we've already met the OS library. This is our module that gives us access to the local file system, but we can also use it just as well to manipulate remote file systems as well. Socket is really where networking in Python starts, especially for you folks in Unix, Linux, and even Mac OS X environments. The TCP/IP socket is an extremely low-level abstraction and gives us deep control over, say, the TCP/IP protocol stack in a programming environment. Email is exactly what you think it is. We can manipulate email messages using those associated protocols, Simple Mail Transfer Protocol, Post Office Protocol, and even the Internet Message Access Protocol, IMAP. You'll see down here we have separate libs for SMTP. There's also a separate built-in POP module as well. In this nugget, we're going to be working with FTP-lib and EuroLib quite a bit. They're exactly what you think they are. FTP-lib is an FTP client library. URL-lib, there's two versions of this that come with the standard Python distribution. They're essentially the same thing, URL-lib 1, for lack of a better term, and URL-lib 2. 2 is considered to have better error handling routines built into the code. However, URL-lib with no number after it is given, I suppose, for those of us who are accustomed to working with that module and already have code that import those functions. HTTP-lib is similar to URL-lib. Really, URL-lib is a higher level of abstraction to HTTP-lib and even FTP-lib. If you want to get really down and dirty with your FTP client work or with your hypertext transfer protocol web page work, then FTP-lib and HTTP-lib are for you. If, on the other hand, you don't want to get your hands that dirty, the URL-lib gives us a nice higher level, more of a touchy-feely interface to do web and FTP work. Over on the technology side of the fence, you see I have references to two alternate builds of Python. We've talked about these in the introductory nugget. We have IronPython for the Microsoft .NET environment and Jython for the Java virtual machine or Java runtime. Now, we've mentioned the Python extensions for Windows before, PyWin32. There's a lot of built-in networking grist in here. However, a lot of it, and this could just be my own skewed impression, but a lot of it seems a little bit old in terms of it relies upon the component object model interface. Now, in this nugget series, we're not doing Microsoft programming, but really the two main engines for Microsoft development are COM, that's the old legacy style, and then we have the .NET framework, which is the current standard. And PyWin32, in my opinion, kind of falls down on the .NET front. Therefore, if you plan on doing heavy Python interaction with .NET, I would recommend you just build your applications from within the IronPython environment. That way you can actually access the .NET framework libraries that pertain to networking. Same thing goes with Jython. We have tight integration with the Java virtual machine and the Java runtime. If you ultimately want your Python code to run or interact with Java, you might as well use Jython. Finally, related sites. We've talked about the Python Package Index, or PyPI. Definitely, if you haven't done so already, check that out. See what libraries are available for free download that do certain networking relating tasks to save yourself some work. Two other sites that I want you to be aware of, very crucial resources for any application developer, StackOverflow.com and ActiveState-Code. Let's just temporarily jump onto the web and I'll show you those sites really quickly. If you've done work in systems administration, you're probably familiar with ExpertsExchange.com. Experts Exchange was really good, in my personal opinion, before it became a subscription service. Now it's only good, I guess, if you pay the yearly fee. At any rate, capitalism in action. Experts Exchange is a community site where you can go in there and ask a technical question, and folks actually compete with each other to answer your question as completely as possible. There are various incentives, ego boost incentives like having a higher answer rating, etc., and I guess there's real tangible benefits as well. At any rate, this site, Stack Overflow, which is currently, as of this recording in May 2010, still free, I hope it remains free, is kind of an experts exchange, but for software developers. The folks who post on here, the answer people, are really, really sharp by and large. And you see some interesting posts, but in particular, what I want to take you to from the homepage is if we go into tags, all of the posts in Stack Overflow are organized by taxonomy tags. We can come down and check out Python, which has an appreciable number of questions, over 23,000 as of this recording. And of course, there's a site search engine, and frankly, if you're doing a Google search, you'll often find that question answered via Stack Overflow on your Google search results. So you go and check out one of the questions and you'll see lots of code snippets and then folks who help out the original poster, etc. Sometimes the only disadvantage I find with Stack Overflow is that sometimes it can be a little confusing because you'll find one answerer goes about answering the coding question one way, then another one says, nope, this is what you want to do. So it's up to you to kind of parse through those responses and figure out which one works. Actually, it's an excellent learning experience for you as a beginning programmer because you can see different solutions to the same problem. The other website I want you to be aware of is at code.activestate.com. You'll recall that ActiveState publishes their own distribution of Python. They have a lot of Python-related products. ActiveState-Code is a code repository. When you hit sites like this and you can download code snippets to accomplish certain tasks, almost always they're for free, these are called code recipes. And you'll note here that Python is covered, also TCL, which we'll talk about in a little while when we do GUI development, PHP, C, and JavaScript. So I'll simply come into the Python section, and again, we have taxonomy tags, etc. It makes it pretty easy to find the recipe you're looking for. You eventually hit the page, and like I said, you'll see rich and robust code snippets that you can just copy or paste out to use as you will. Sometimes these are completely free for the community use. Sometimes the author asks that you provide attribution. You'll just have to read the instructions. For our first demo, I'm going to show you accessing LAN resources in Python. We're going to make use of just standard built-in modules, built-in libraries, and because I am in a Windows environment now, it's most convenient for me to give you this example with what Microsoft calls Universal Naming Convention, or UNC paths. What you're looking at right now is a Windows Server 2008 R2 machine called WinNugget01. And what I'm going to do is just show you that at this time I've created a shared folder called, well, not too much imagination here, but I've called it share. And in there I have just a single text file called serverfile.txt, just as an example. So that's what we've got going on the Windows machine that hosts a shared resource. Next, let's move over to the Python shell. In this nugget, as a departure from what we've been doing thus far, I'm going to be using Python 2.6.4 instead of 3.1.2. The reasons for that is some of it you, I'm sure by now, can already answer. Python 2 has a much bigger foothold in the market, and especially when we start importing third-party modules, and a lot of the networking recipes that are out there on the web are written for Python 2x and not 3x. I also think that using Python 2 here gives us a good opportunity to take a look at some of the major differences between those two versions of Python. Now, without any further ado, let's get to work. To that end, let's begin by importing the OS module, and we'll declare or define a name called D that invokes our friend os.listdir. You remember this function, of course. And here, instead of passing in a local path on this machine, I'm going to pass in a Universal Naming Convention, or UNC path. I want you to see that we're making use of our escape characters, aren't we? Because UNC paths begin with //. We need to be unambiguous in our usage of those backslashes. So I've escaped them twice, and then between the server name and the share, I've also escaped the backslashes there as well. And you'll notice I'm using the IP address of the target server just to avoid the name resolution issue. Of course, if we had a hosts file on this machine, or if we were using domain name system, DNS, we could supply the partial or fully qualified domain name of WinNugget01. However, as I said, I'm just using an IP address in this case. Now, once I hit enter, you'll notice that there was a pause there as this IP address was contacted, this share was connected to, and if we do a type on D, we're getting back a list, which makes sense, because remember, list dir gives us that. We run a D, and that's in essence performing an ls or a dir command on this remote location. We already know about server file. Let's say we want to add a file to that shared location. Of course, it goes without saying, although I'm going to say it, that our currently logged on user account needs to have write access to that shared folder, which I've made sure is the case. Now, how do you think we can create a new file in Python? Well, we're going to create a new name, and we will use, I hope you're with me here, the open function. Remember that. And in this open function, we need, I missed a quoted string that represents the new document to be created. In this case, I'm calling it test.doc.txt, and we're opening the file handle for writing. There's the W. Now, if this file doesn't exist, a new one is going to be created. If there already was a file named test.doc.txt in that location, we would be blowing away all of its content. So we want to be careful using this command, obviously. Blessed syntax, right? The IO error we get is no such file or directory. And quick debugging tells us that the problem here is that we forgot to escape the final backslash. So let me throw that in. And we have ourselves a file handle. Let's start writing immediately. And when we're finished writing, let's close the file handle. If we come back to WinNugget01, as expected, we have a new file called testdoc.txt. And if we open it up, there's the contents. Good and good. The second example I want to show you is a recipe that I've adapted from a post at stackoverflow.com. And the purpose of this script that I've named filecopy.py is that it's going to use some of the modules and functions that we've been learning about thus far. And actually, this is going to perform a batch copy. Let's walk it through here. Now, the process of walking through code, parsing it, and giving it user-friendly definitions is also done in a written form. Oftentimes, when you're designing a program, you'll just write the program out logically without heeding the specific syntax you need. This is an important programming principle called pseudocode. So we would do something like this. Import OS bulk copy module. Let's say you forgot that you needed shutil. Then you'd say something like create proper or create correct source path, create correct destination path, and then you'd do something like this. Loop os.walk source path copy text files to destination. You see what I mean? This is called pseudocode, where you're working through the problem set and how you want to solve it, but you're not yet concerned about the specific Python syntax to do that. Keep that in mind as you're developing new applications. So anyway, we're actually going to do just what that pseudocode was talking about. We're going to import the appropriate libraries. Both of these come from the standard library, OS and the shell util. We're going to use OSPathJoin to build our source path. This is going to be C files on the local computer. We've seen this directory quite a bit in earlier nuggets. We're then going to create a name for our destination path. We're again invoking OSPathJoin, and this time we're building a universal naming convention path, 192.168.106 share. No surprise there. Now, to do a bulk copy, where in this case we want to grab all text files, a for loop makes sense here, along with the OSWalk function that we've also met earlier in our training. So this is an embedded for loop that, in a sense, just iterates through the path, C files, looks for files that end with .txt, and then finally we invoke shellutil.copy to perform a copy. Now what you're seeing here is a construct that we haven't yet gotten to in our training, and that is exception handling with try and except. So by wrapping this call to shellutil.copy in between try and except, we can handle, if we do get an I/O error, which with a file copy is the most likely thing that can go wrong in Python, we can capture that by gathering the message text and just printing it out here. More on exception handling in a future nugget. Before we run the program, let me show you C files on my local system. And as you see here, we have a pretty good handful of text files. So we should expect that those files get copied over to WinNugget01. We'll open the Run menu, choose Run Module, no feedback because we didn't program any in. If we come to WinNugget1 and open up our C share folder, sure enough, there are the files copied. Easy peasy. Accessing web pages in Python. Now I refreshed your memory with the open function and how we can use it to create a file handle for read and or write access to binary or just ordinary text files. I think if you're comfortable with that, you'll certainly be comfortable with the web page method. That is to say, if we import URL_lib or URL_lib2, we can invoke the built-in URL_open function to create a file handle and allow us to drill into a web page. A web page is formally defined as, well, a file that is arbitrarily given HTML or perhaps .htm as extension and is parsed or processed by a web browser that displays hypertext, right? In fact, our parent protocol is Hypertext Transfer Protocol. Now, there's a whole discussion that some geeks like me get into as far as when we're dealing with URIs versus URLs. That's beyond our scope. However, I do want to draw your attention to a wikipedia.org article on Uniform Resource Identifier, and they've given what I think is pretty much the best definition of the distinction between the URI and the URL, because you'll see this in the literature, references to URI and URL, and you're probably thinking like me, well, what's the difference? Let's look at this text here. One can classify a Uniform Resource Identifier as a locator, and specifically, as you see from this Venn diagram, URL is a subset of URI. So URI is a general identifier. URL, Uniform Resource Locator, specifically locates a network resource. There's a third category of name called the Universal Resource Name, or URN. Wikipedia says the URN functions like a person's name, while a Uniform Resource Locator resembles that person's street address. In other words, the URN defines the item's identity, while the URL provides a method for finding it. That's a really good distinction there, and it's pretty much all we need to worry about now. In Python, we talk about URLs, and that gives us a specific locator to a web-based resource. So, for instance, we could drill into http cbtnuggets.com/sales, and that's telling us specifically how we can get to the default web page in that sales subdirectory on the CBT Nuggets web server. Not only do we get in a URL the specific location of the resource, but we also get how to access the resource. In a URL, you have what's called the scheme, HTTP, HTTPS, could be FTP for local resources, it's file, etc. Now, all of those schemes work just fine with URL open. So you could write a URL open call that creates a file handle to a locally stored file. It doesn't have to be HTTP out on a public web server or an intranet web server. The distinction that I need you to understand between URL open and just regular open is that with URL open, we're dealing with read-only access. Thus, if you're going to do something with that web content, you're going to need to bring it down read-only initially and then perform some transformations to get that data in a position where you can actually modify it. As previously discussed, URL_lib is considered an easier method for doing HTTP and FTP than, for instance, HTTP_lib. HTTP_lib is a really low-level client interface to HTTP. It enables you to do some things that URL_lib either cannot do or it's actually harder to do in URL_lib. You can post to websites in addition to pulling down. It's the post method of HTTP, as opposed to when you're downloading, that's called the get method. At the end of this training, I'm going to turn you on to a whole bunch of Python-based frameworks. Most of them are web-based frameworks. One that's relevant now for a brief discussion that you should be aware of is called Twisted. Twisted is an event-driven networking framework. It puts Python and TCP/IP networking on steroids. You certainly want to consider this if you plan on using Python for heavy web work. The Twisted project page is twistedmatrix.com/track, and you can download this open source software just by visiting the page and downloading whichever version you want. Notice that it comes in source, tarball, or you have a Win32. Again, notice that the Python dependency here is Python 2.5 and 2.6, so keep that in mind. Let's now do some web work, and like the previous demo, we'll start from the Python shell, the interactive interpreter, and then I'll show you some stored script files that are relevant. We're going to begin by doing some imports here. We'll import URLlib, and I'm also going to import sys, because as we've come to know, the best way to parse through all the lines of a file, whether that be a web page or a text file or whatever, is generally speaking by using a for loop instead of doing the read method that takes in the entire document in a single string. What I'm going to do here is define a name called WP, and I'm going to call URLlib, URLopen, and pass in cbtnuggets.com. To iterate through the lines in that web page and show those on the standard out, just on the screen, we're going to open up a for loop for line in WP. I'm going to call sys.standardout.write, pass in line, and then we're going to print out WP. Well, we'll do that later. Let's just hit enter and go ahead. Now boy, the screen scrolled by very fast for a very long time. I don't know if you were surprised by what you're seeing or not. What you're seeing is the actual content of the CBT Nuggets homepage. Not as it's parsed and rendered by a web browser to give you a pretty interface, but the actual content of the file. Remember, that's what we're dealing with. The actual underlying content that includes all of the XHTML and cascading style sheet, perhaps JavaScript. In fact, we definitely have JavaScript involved in this page. Here's a couple calls to Google Analytics, as a matter of fact. You can call another interesting method in URLlib called info. I'm going to print, actually we're on Python 2 here, so I'm just going to, instead of using the print function, which doesn't exist in Python 2, I'm just going to type print space wp.info. This invokes the info function on the WP object. And info is cool to give you metadata regarding that web server. So it's telling us what operating system that web server is running. When the page expires, that's useful for DNS and caching, etc. P3P is a privacy policy specification. Pretty interesting stuff. Gives us the page character set, etc. Another interesting method I want to show you is the getURL, which can be useful to ascertain when a website or web page is redirected. You can see what the actual source or redirect source is. In other words, let me just show you this rather than try to explain it. I'm going to do another URL open, and this time I'm going to pop in http microsoft.org. Now what do you think would happen? Is this going to 404, or does Microsoft own the microsoft.org domain? Well, let's find out. First we make a connection, so we've now captured this page to a file handle, and what we can do is call getURL, and we get back what the redirect is. I guess it's not the redirect source, it would be the redirect target. URLlib also includes a really nice method called URL retrieve. And what's neat about this is that you can capture the content pretty much as it appears in a web browser, minus images and other interactive elements. So check this out. The first argument in URL retrieve is the source web page. Here I'm going to use www.python.org, then comma, and then you specify your target path. I'm going to choose C files, py.html. So it's done that, and there's py.html. Let me right-click this guy, open with Internet Explorer, and now I have the content of that page framed in a web browser. Of course, again, we don't have those pictures, but we have all the links, the styling pretty much as it appears. I mean, you're not getting the full cascading style sheet, that's a separate file. If you hover over the links, you'll see that they're HTTP links. So you can click them and they'll resolve correctly. At least external links will. Just for grins, I wanted to show you a simple script that involves the HTTP lib. And what we're doing in this simple program is that we're first creating a list where you can pass in a comma-separated list of as many pages or subdirectories that you're interested in hitting. Here it looks like I'm trying to retrieve the root homepage of the site and also the default page for the doc directory. So just a couple pages. Of course, you can use this to gather entire websites if you want as well. We're We're then creating an HTTP connection object called H that involves the HTTP connection function, passing in the URL and the port number. We're then opening a connection and running an iterator to gather the data. Here we're just pulling an entire read, which is going to grab the whole contents of each of those files and put them on the standard out, in other words, the screen. So let's run the module, and after a moment's pause, you see the raw HTML from both of those pages at python.org. Before we get back to the whiteboard and we finish up this nugget with a consideration of FTP connectivity from Python, I wanted to show you one more script file. This goes out of the web stuff and back to what we were talking about initially about LAN access, in particular Windows networking access from Python. This is a very small script that I've adapted from a neat site called ozoneasylum.com. And the first thing it does is import a module that's not part of the standard library. What I've done here is installed PyWin32, the Python extensions for Windows. This is one of the modules in that collection. So first we're grabbing all names from Win32WNet, and then from Win32Netcom, we're grabbing just the resource type disk method, and we're aliasing it as disk. This alias as keyword should be familiar to those of you who understand structured query language or SQL. It's the same thing there. It just makes the identifier easier to reference. So what this is doing, mapdrive.py, should tell you that we're going to map drive R in this case to a network path. It's mapping a network drive that you Windows administrators certainly know all about. Now we could modularize this function. We could do lots of different things to abstract the drive letter, to add multiple paths, etc. This is just a simple example to get you going. First, we declare R as our drive letter in this case, another name called path, and this is going to be the universal naming convention path to that shared resource that we know and love by now. The actual mapping is done in PyWin32 with just a single function call in Win32WNet, WNet add connection to. The two arguments are disk, drive letter, actually three arguments, sorry about that, disk, drive letter, and path. Let's run this module, and then by opening my computer on my local host, we can see we have a network drive mounted, share on 192.168.1.106, and we can double left click it and now access all those text files that we had in there that we copied from our earlier example, just as if these resources existed on the local machine. Finally, let's consider how to use Python as an FTP client. FTP, of course, stands for File Transfer Protocol, and it's used for the transmission, the uploading and downloading of files as an alternative to, say, email. Those of you who have done router, switch, and firewall configuration are also familiar, I'm sure, with Trivial File Transfer Protocol, or TFTP. TFTP is a protocol optimized for the transmission of smaller files, like router firmware files. Now, of course, we can get to FTP client connectivity using FTP Lib. That's what we're going to do in this demo, as a matter of fact. But I also want you to be aware of external modules that can be helpful to you in this regard. The Chilcat module for Python 2 really puts FTP on steroids in Python. It supports FTPS, which is a secure FTP, or strictly speaking, it's SSH, used in an FTP context. And as I've mentioned several times thus far, URL Lib provides a higher level interface to FTP client functionality. So you can just go out onto the web and look for Chilcat. He has a tremendous number of really great examples, recipes. This one here that we're looking at shows a simple FTP download, and it relies upon his Chilcat Python library as well as the sys module to unlock those possibilities. So, as has been our standard in this nugget, we're going to start with the interactive interpreter and then get into script files again, this time focusing on file transfer protocol. I'm going to start with using our alternate method of importing. This is importing a specific name from the FTP Lib module. You remember the syntax, right? From module name, import FTP. Remember, the benefit of doing it this way is that we're cutting down on our RAM footprint by importing only what we need from a certain module. And we also have the benefit of being able to access this FTP function without qualifying it as ftplib.ftp. I'm going to create a name called FTP that invokes the FTP function, and the tooltip help tells us that we need to supply a host and then optionally a user argument, a password argument, a count argument, or perhaps even a timeout as well. In this case, I'm simply going to do quoted string ftp.redhat.com because I know they offer anonymous access. Now we've created an object, a connection object. We'll run type and we have an instance. FTP is actually a class, strictly speaking. And what we did in this line is instantiate an instance of the class FTP. Kind of like a function, but actually much more powerful. And we'll be talking more about classes and object-oriented programming in a future nugget in this series. Next, what we'll do is we'll invoke the login function. Now this is where we actually pass our credentials, if we have them, to the FTP server. Something like this, user, comma, password. If you want to do an anonymous login, if the FTP server accepts that, we can just pass in login with no arguments at all. I'm now going to create a name called D that's short for directory. And I happen to know that I want to delve into the Red Hat /Linux subdirectory. We can then call ftp.cwd to set our current directory either to that path or just invoke the name to modularize it a little bit. If we want a directory listing, we could have done this initially, of course. We can print, and remember, we're in Python 2, so print is a statement and not a function. We can run print ftp.dir, and it gives us a very Unixy directory listing from the current working directory, which is Red Hat /Linux. Now there's plenty of things we can do at this point. Assuming we have upload privileges, we could certainly put resources there. We can open up a file handle and open up a file if we see one, like perhaps README here. This isn't going to get us very far on Windows, but on a Linux Unix machine, we'd be able to read that file just fine. What I'm going to do, though, is switch over to our final script file of this nugget, a file called ftpdownload.py. This is a script that I've adapted from another really great Python-related site called fbot.org. And after we get our imports out of the way, we're declaring a couple functions here, ftext and fbin. Basically, the first function fetches a text file. The second function fetches a binary file. So a binary file would be perhaps an image, it could be executable code. A text file is exactly what you think, Unicode or ASCII text. After we do the function declaration, you're seeing here we're opening up a handle to ftp.redhat.com using the FTP class. We're actually creating an instance of that class. We're logging in, just what you saw in the interactive prompt. We're creating a name to store a path here, Red Hat DST 2007 README. We're changing our directory to that location, and then we're going to run not the fbin, you noticed I've commented that out, but we're going to run ftext, and we're going to pass in the FTP class instance, and then the name of the file that we want to grab from the server. Now you're probably thinking, well, how do we know the name of that file? That's kind of given in this example that I've already visited this site and I know what resources we want. But just as well, of course, we could perform scans, seeks, searches. We could get a file name from the user. Lots of different ways we could go. Here I'm just hard coding it for the sake of example. Finally, let's come up to ftext and take a look at what's going on under the hood. The fetch text function has three parameters, FTP, file name, and outfile. Notice that we're using keyword assignment here, and none is the default value. So we could, if we wanted to, pass in, as we do down below, the FTP object and then the name of the file that we want. And we're not specifying an outfile because that's the default anyway. If outfile is none, what I'm doing here is opening up a file handle. To my local file system, I'm going to create a file called outfile.txt, and you remember you do that with the right parameter. Once we've done that, once we've connected to the server, we've created our outfile, we're calling ftp.retrieveLines. We use the retrieve lines or retrolines to be more accurate method to grab lines out of a text file. If we're pulling down a binary file, we can use retrobinary. But something else that's new that I'm just going to briefly touch on here, it's beyond our scope. It's called a lambda expression. It's a really nice way to create what's called an anonymous function that does work. So we've got a function overall, and then inside the function to retrieve the lines, we have an internal function. So what's happening here is we're passing in the specific FTP command. RETR is FTP speak for retrieve or get the file. Then we're passing in the name of the file, which is going to be readmefirst.txt. And then to actually add the new lines to the lines read from the file to make it a little bit easier to understand, we have an embedded function. Embedded anonymous functions are called lambda expressions. And an anonymous function is a function that has no name. These two that are in this file are discrete. They have names. We call them by name in our code. Lambda is where you want to be able to pass in arguments and do some kind of expression, but it doesn't need its own function declaration. It actually occurs inside of an already existing class or function. So that's what's happening with that. Without any further ado, let's run this guy. And it's finished, and I forgot to explain the final line in the program. It tells us our current working directory is CPython26. Before I forget, let's navigate. I'll pop open that Python26 folder and verify that we do in fact have an out file created. And sure enough, this is the content. These are the lines from the file that we nabbed from the FTP server. So if I come back in the Windows menu, I'll select ftpdownload.py. The very final thing I had here was a print statement where the string literal was current working directory is, and then we invoked os get current working directory, and then threw in a new line. Accessing the LAN and the Internet review. In this nugget, I showed you how we can use Python to connect to servers in a Windows environment, but I've certainly given you the proper heads up with regard to modules, functions, recipe websites, etc., such that you can adapt what you've learned in this nugget to Unix, Linux, and Mac OS sharing situations too. In the second half of this nugget, we went out onto the web and we looked at the URLlib and FTPlib libraries in particular to interact with web content as well as file transfer protocol or FTP sites. I hope that this has been informative for you, and I'd like to thank you for viewing.